Chapter 4, Lesson 2, Solving Quadratic Functions by Graphing. So we're going to take a look here. Now, these quadratic functions, solutions, okay? The solutions, the roots, zeros, x-intercepts, these are all basically the same thing. They're meaning the same thing, okay? So we're going to use a graphing calculator or Desmos online calculator to find these solutions to these quadratic functions, okay? So let's take a look here. We have x squared minus 3x minus 4 equals 0. So let's plug that into our graphing calculator. All right, so let's pull up our graphing calculator here. And we're going to type in x squared minus 3x minus 4. So there's our graph. You can see. Now, we talked about roots, zeros, and intercepts. It all depends on what you're using to calculate your solution. Okay, so we're using graphs. So x-intercepts is what we're looking for when we're graphing it. Okay, so x-intercept, x-intercept. If I click on them here, -1 and 4. So when I look here at my solution, x equals -1 and 4. Take a look at number 2. Plugging it in. X squared plus 2x minus 15. So x squared plus 2x minus 15. Again, there's my graph set up nice and neat for us. Okay, big parabola. Solution, x-intercept, -5 and 3. So answers for my x-intercepts here. So x equals -5 and 3. So those are my solutions, my roots, my zeros, my intercepts. Okay? Now, biggest thing is when we're looking at these, make sure that these are in standard form, that this is set equal to 0. Okay? You don't have to put that equals 0 in there, but just put in this first part. If it's set equal to 0, put in that no equal sign, and you can get your graph and find your solutions. Okay? So we have a couple different options for these solutions. We have two real numbers, so let's go ahead and sketch a little coordinate plane on your chart there. So we have y, x, and again you can do this for all of them here. So let's group those together. And clone those. All right, finally got my coordinate plane set up there. Now, two real solutions. We just saw two examples of two real solutions. So this graph comes down, touches the x-axis at two spots to give us two x-intercepts, giving us two real solutions. Okay. Now, the graph could open down. So my graph could come up, cross over, boom, two real solutions there as well, because again it crosses at two x-intercepts. So that's option one, two real solutions. Option two, one real solution. So I can have a graph come down, opening up, graph comes down, the vertex is right there on the x-axis. So I only have one real solution there. Same thing, graph could be opening down, so it can come up, touch vertex on the x-axis, and go back down. So again, I only have one real solution there where that graph crosses the x-axis. Now, a lot of these times, these roots here are called double roots. Okay, and we'll talk about why they're called double roots later on. And we can have no real solutions. So just like before, no solution answers where this graph is above the x-axis, opening up, never touches the x-axis. So there's no real solutions there. Same thing, graph opening down, and it can be below that x-axis, so it never touches the x-axis. And so I have no x-intercepts there. So again, two solutions, two x-intercepts. One solution, one x-intercept. No solutions, no x-intercepts. And that's kind of what we're looking for when we're taking a look at these graphs. So again, set this thing equal to 0 first. So if I get an equation like letter A here in example 2, let's get it set equal to 0 first. So I'm going to add this 8x over. And if you want to do this in one step, you can do both in one step. And I get plus 8x on the left side. So x squared plus 8x plus 5 equals negative 11. Those cancel. And then I'm going to add 11. So if you want to do that in one step, I'm good with that. So now I have x squared plus 8x plus 16 equals 0. Now I'm going to plug that in Desmos. So go ahead, take a minute, plug this into Desmos, see what you get in your answer, and then double check your answer with what I have here. And then same thing in letter B. Plug it in, get your solution, pause the video, check your answers here with mine. Alright, so x in the first one, A, one solution, x equaled negative 4, and again we call this a double root. Okay, so go ahead and finish number 2. So x equaled negative 4 and negative 2 for your graphs there for part B. Alright, you see your homework down the bottom right.